Hello friends, let us now learn some important points about the silicon rectifier. Okay. Silicon rectifier. A single silicon rectifier can resist a reverse voltage of almost 1000 volts. So this is almost 20 to 30 times more than the selenium rectifier. But we will learn about the advantages in a minute. But here silicon rectifier can resist a reverse voltage of 1000 volts. That means that if this is connected to, if in the electric circuit, if we have collected a silicon rectifier, if 1000 volts of current, 4 volts of voltage potential, 1000 volts potential is trying to flow through this rectifier, it can stop a reverse voltage of 1000 volts. So generally if the electron flows from negative to positive, or if the current flows from positive to P to N, that is if the electron flows from N to P, or if the current flows from so before we go this, let me show you this one so it becomes easier. See, if normally in forward bias, which we have learnt in the last class, in the forward bias the positive terminal of a battery is connected to the p-type semiconductor and a negative terminal of the battery is connected to the n-type of semiconductor. So if a positive terminal connected to p and negative to n-type of semiconductors, this will allow the flow of electrons from the negative pole of battery to the n-type of semiconductors, and from n to p the negative or electrons can easily flow, and from p the electrons can again flow. So the electron flow from N to P, the flow of electrons, the direction of flow of current is inversely proportional to the direction of flow of electrons. So that means the direction of flow of current is opposite to the direction of flow of electrons. So if electrons are moving in this direction, meaning that the current will flow in this direction from P to N. So current flows from P to N, whereas the electrons flow from N to P. So so current flows from P to N, right? If we pass a current from N to P, do you think it flows? Definitely it won't flow. So the silicon, that is the main use of rectifiers. So rectifiers will allow the current only in one direction. So a rectifier will allow the current only from P to N type semiconductor, P to N type of semiconductors, but it will not allow the current to flow from N to P type of semiconductor. So that is simple. So here silicon rectifier can stop a reverse voltage, that is flow of voltage in opposite direction of around 1000 volts. It can stop the flow of voltage of around 1000 volts, and it can withstand the temperature up to 392 degrees Celsius also. So these two are higher when compared to the selenium rectifier. We will see in a minute. So how is a silicon rectifier made? A silicon rectifier is made up of multiple number of cells or multiple individual diodes, and they are connected together to form a cylindrical stack. And this cylindrical stack will have a dimensions of around 20 to 30 centimeters in long or length. In length it will be 20 to 30 centimeters, and it has a diameter of 20 millimeters. That means number of cells of silicon or number of diodes, multiple number of diodes are connected with each other to form a cylindrical stack which has a length of around 20 to 30 centimeters and a diameter of around 20 millimeters. These silicon rectifiers are most commonly used in modern X-ray tubes or X-ray equipment. So this is important. So as we have said in the last class, selenium is the first material to be used as a semiconductor. But now the silicon rectifiers are most commonly used. Why? Because silicon can resist a reverse voltage of 1000 volts, whereas selenium can resist reverse voltage of 10 to 20 times less than that of selenium. So it can only resist reverse voltage of 50 to 100 only, whereas the silicon can resist higher reverse voltage. Then silicon can also withstand temperatures of around 392 degrees Celsius, whereas selenium can withstand temperature of around 266 degrees Celsius. Now let us learn some important points about half-wave rectification. So in half-wave rectification, we have already told you that one form of half wave rectification we have seen in the last class, which is actually the X-ray tube itself. Now this is the other type of half wave rectification. In half wave rectification, the two rectifiers are connected in series with the X-ray tube, and to these two rectifiers it is also connected to the secondary circuit of step-up transformer. Okay, now the electrons. So what happens, we will see. See, this is the. So if you see, if the electrons will flow in the primary circuit, this will induce the magnetic field, and this magnetic field, whenever there is increase in the magnetic field, this increase in the magnetic field will induce current flow in the secondary circuit. In the secondary circuit we have two rectifiers and an X-ray tube connected in series. So this and one end of the wire of the secondary coil is connected to the rectifier, and the other end of secondary coil is also connected to other rectifier, and both these rectifiers are connected to cathode and anode respectively. Now the electron will flow from this. Just imagine that the electron flows in this direction. So when electron flows in this direction, here electron will flow. This is N to P. Flow of electron from N to P can occur, but flow of electron from N to P, meaning that flow of current from P to N. So this is possible. So the electrons will flow from N to P, and from here they reach the cathode. Once they reach the cathode, this cathode filament gets heated, and this will cause flow of electrons, emission of electrons, and these electrons accelerate towards the target anode. When they accelerate towards the target anode, this results in production of X-rays. Now the electrons from this second will move to the opposite side, and here this is again N and this is P. So from N to P the electrons will flow. So as a result the circuit is completed. This is whenever it occurs in one direction. So the first direction. So this is the alternating current which is given to this secondary circuit. So in first positive potential there is flow of electrons, so there is X-rays are also produced. Then in the second half of cycle, in the second half of electric current, so the electrons will, the flow of current is decreased, meaning that the magnetic field is decreased. So whenever there is decrease in magnetic field, the electrons will start flowing in opposite direction. So here from B to A the electrons will flow. So when electrons are flowing like this, so this is P and this is N. From P to N there cannot be flow of electrons. Electrons cannot flow from P to N. So these electrons cannot reach the target anode. Previously when you have seen the usage of X-rays has rectifier, in such states the electrons will reach this anode, and this anode gets heated, and as a result the electrons from anode will accelerate and they bombard the filament and damage the filament. So this problem has been corrected with the use of two silicon rectifiers. Okay, so this is called as half wave rectification, where in the whole electric current only one half of electric current is utilized in production of X-rays, whereas the other half is not utilized in production of X-rays. The main disadvantage of this half wave rectification is that it requires more exposure times than the full wave rectification. Okay, then we have the next thing which is introduced, which is called as full wave rectification. See, in full wave rectification, the modern X-ray generators will employ this full wave rectification, which utilizes the full potential of the electrical supply. That is, both the positive potential and negative potential, both these are utilized in the production of X-rays. So X-ray output in a full wave rectification is almost twice the X-ray output seen in half wave rectification. Both these halves, both first half and the second half, both these halves are utilized in production of X-rays in a full wave rectification. So this is the diagram which is showing full wave rectification. So in full wave rectification, this is the primary circuit, this is a step-up transformer. So this is the primary circuit. To the secondary circuit, one end is connected to four different rectifiers, which is labeled as R1, R3, R2 and R4. These are the four different rectifiers. So what happens, we will see. First, when electricity or current passes through the primary circuit, when current is increasing, there is increasing magnetic field is induced. This increasing magnetic field will induce current in the secondary circuit. Current is nothing but flow of electrons. So first just think that A is negative and B is positive. So electrons will flow in this direction. When electrons will start flowing in this direction, they will go to R1, and from R1, this is N, this is P. So from N to P, electrons will pass. So the electrons will see from N to P, the electron, this is N, this is P. So from N to P, the electrons can pass. So electrons will pass in this direction. See here in through R3 it cannot go because this is P, this is N. So electrons cannot flow in this direction. So they flow here like this, and they move from the filament. They go from filament to the so the filament gets heated. So when filament is heated, the electrons will travel from the cathode filament to the anode, target anode. So the electrons will go like this, and in the reverse cycle, so the electrons will flow from N to P, so they can flow like this, and they will reach the B terminal. So as a result, the X-rays are produced. So in the first half of X-ray of electric current, the X-rays are produced. Then if you see the second half, in the second half there is decrease in the magnetic field. Here there is increase in magnetic field. Whenever here there is decrease in current, whenever there is decrease in current, there is decrease in magnetic field starts to decrease. So when magnetic field starts to decrease, this will induce the current in opposite direction. So when the current is induced in opposite direction, that is from B to A. So these are the electrons will pass like this, and here, so when they try to pass from R2, this is R2, R3, R4, R1. So electrons, when they try to pass through R2, it is from P to N. So electrons cannot flow from P to N. So electrons will flow from N to P. So they will reach R3. So from R3, again here at junction, it has two options. It can either go to R1 or it can go to X-ray. So from like this, here they go, and from R1 they cannot move R1 because it is from P to N, so it cannot go through R1. So then the electrons can go through the X-ray. This is cathode, so they go through the X-ray and the X-ray tube. Now cathode gets heated, electrons are accelerated from cathode to the anode, and anode is bombarded. So this results in production of X-rays. Now the electron will again go through this, and from here the electron has two options, N to P, or they can go from N to P in this way. So here the electrons will go like this. So even if the electrons will go in this direction, the electrons they won't go to the same side, right? So and here it is like it will be a circuit, so they will go in this direction. When they go in R4 direction, and then from here, because it is N to P, so electrons can flow in this direction. Again they can go, and they can go to the A. So the second negative potential also, there is flow of X-rays. So X-rays are produced with both halves of the electrical current, not just one but both the halves of the electric current. So this is the main advantage. So here if you see, so here the voltage in the tube, here the voltage, so this is, so with the help of these four rectifiers, the pulsating current, which is alternating current, is converted to pulsating direct current or unidirectional current through the X-ray tube, and this will produce the X-rays. Though the X-rays are produced in full potential, that is in both halves. So in the first half also X-rays are produced, in the second half of electric current also X-rays are produced. But still the main problem here is that the X-rays will start from 0, they become maximum, and again they become 0. Again they will increase, then again they will decrease. So that means in this half of cycle, if you see, if this is the voltage produced, okay, so I am drawing a curve with X-ray tube voltage and with time, and in this side I am drawing X-ray intensity. Okay, here the voltage of the current increases and then decreases. Intensity of X-rays produced will also increase to maximum and then decrease. So in the other, if you see the next one, this is the second diagram where intensity of electrons will increase and decrease. Means that here in this the X-rays are generated during the central high voltage portion of the cycle, whereas the peripheral, this low voltage of the cycle, the X-rays produced are not useful. So good useful electrons are only good useful X-rays are only produced in the central half of the central portion of the central high voltage portion of the cycle. So this is the main disadvantage. In this, the considerable time portion here, the before this high voltage, central high voltage part, and before after the central high voltage part, these two things are lost. So considerable portion of time is lost and quality X-rays are not produced. So when in between the two high voltage, see, this is one high voltage part, this is the one high voltage part. In between in this part, the X-rays produced do not have the proper quality. The quality of X-rays produced are very less. So this is the disadvantage. So in the next chapter we will see the how to use this, how to even remove this part and make good quality X-rays even in this portion of the voltage. Thank you.